What is a really convoluted way to say this? Welcome back to part 2 of the series on the series of lectures on magnetism delivered by Ken Wheeler. Catchy. So far in part 2 of his lecture series, Ken has been railing against quantum mechanics and asserting that Mother Nature, according to quantum mechanics, is a cross-eyed hooker on crack. Literally. He also asserts that wave-particle duality is nonsense, as
quantum mechanics has utterly co-opted the definition of magnetism along with the source of quantum's religion, that being light. But quantum is atomistic. Its very foundation is built upon the wave-particle duality, of which light is certainly not a particle and a wave is absolutely not a thing.
And then there is a very silly statement about skyrmions which he claims don't exist and that they are just part of the so-called particle fantasy. He discusses these skyrmions as it is a pretty esoteric topic, and it makes him sound clever, as no one in his audience would have ever heard the word before. He neglects to mention that skyrmions are not actually proper particles and that there is plenty of experimental evidence considering that they have been directly measured. Now, I repeat this point as it will get funny in later lectures as these magnetic textures or these skyrmions pop up in later parts of his lecture series and he won't even realize it. But let's start watching the video and I'll quickly get changed while you watch the first segment.
This is from Nikola Tesla. There's a great one. Quote from Richard Feynman, or Tricky Dicky. All literature on this subject, reality and curved spacetime, is futile and destined to oblivion. Nikola Tesla. Here's a quote from Tricky Dicky Richard Feynman. And I have his books, by the way. This guy had 1 million charisma points and he was an insane idiot. Absolutely insane. Everybody loved him because he had a great personality and he played the ukulele and the drums, and you know, he was just, man, college kids loved this dude because he was hip, but he was also a moron. This is his own statement. Anyone who claims to understand quantum theory is either lying or crazy. Well, that's a brilliant statement. I'm glad he could be so forthright.
Yes, it is a brilliant statement, and clearly you don't understand it. So this must be some sort of meta misunderstanding. But I will forgive that one, as many people don't really get it. Quantum mechanics is a rather elegant framework which we can use to describe how things at a very small scale work. It is terrifyingly accurate. The problem is that we don't actually know what it actually means. And this is where the different interpretations of quantum mechanics come in. What Feynman is saying is that if someone claims that they fully understand quantum mechanics, they are claiming that they know which interpretation is correct. They can only claim this if they haven't fully understood the different interpretations, because if you do fully understand them, then you would realize that each interpretation has massive problems.
This is also from his book, QED Strange Theory of Light and Matter by Richard Feynman. This is a really good one too. A virtual particle is an abstraction which facilitates in calculations and understanding. The term is very vague and loosely defined. They never appear as inputs or outputs of experiments done. Their existence is questionable at best. However, they are very useful in rendering concepts and making equations balance out. Well, isn't that interesting? That sounds like something straight out of the padded room section of your local mental ward. Now, this is a really good one. This is the official priest of the cult of quantum, PhD, doctoral professor of theoretical physics, Leonard Susskind. This is a real quote. When common sense and intuition fails, we had to create a new form of intuition based upon abstract mathematics. When common sense fails, we must create uncommon sense.
Well, yes, because common sense was not able to explain the experimental results. Turns out that our common sense is designed for making sense of things that we commonly encounter, not quantum stuff.
Well, isn't that nice? Isn't that lovely? That just seems so lovely. This is a good one. Here's the idiot at work.
Ooh, a meme. Yay, cool. Let's see if I can do one too. Yeah.
This is the premise of general relativity. Yeah, magic, virtual, invisible virtual particles. That's how we do instantaneous action energy. That's what's going on with magnetism there. No, no. This is a postulation based upon no science nor any experiment. By their own admission, this is a fantasy used to make equations balance out. So, and here's Nikola Tesla's quote on these type of idiots. This is from Tesla. The scientists of today think deeply rather than clearly. One must be sane to think clearly, but one can think deeply and be quite insane. Very true.
I don't think that I need to point out the irony here. Oh, by the way, that was apophasis, a rhetorical device wherein the speaker brings up a subject by denying it or denying the need for it to be discussed.
There is fundamentally, let's get on to magnetism and leave these idiots behind. There is no fundamental action at a distance which implies lack of interconnectivity, since the field surrounding a magnet is ab extra to the magnet itself, and only the pressure mediation of the medium or ether itself. The magnet does not have a field, rather impresses of the medium the field structure to be necessitated. This, of course, explains in simplex ether hysteresis, electromagnetic retardation, as well as countless other things, in a simplex and logical fashion. To speak conventionally only about any magnetic pole is inept, since there are palpable pressure zones. By any Gauss meter or even the supercell, you can actually show the rate of flux, but not the nature of flux. And we'll talk about that in the next few sections, when we'll clearly illuminate what's going on so that you have an understanding. This notion of, well, here's the North Pole and here's the South Pole, doesn't work that way. It's high in the center so far as the pressure, then it tapers off, then increases to max at the edge, all of which is viewable underneath the supercell, all of which is palpable using bismuth, all of which is also measurable with a Gauss meter.
And it is now possible to order your very own word salad. The lovely people at Botnik will now allow you to customize and order your own Ken Wheeler branded bullshit. The link in the description will take you to the website where you can select your favorite ingredients. Let me know about what word salad you get in the comments section.
So let's define magnetism here very soon. Suffice to say, there's no such nonsense as magnetic attraction, nor is said phenomena a force. Likewise, a magnet does not possess or have a magnetic field. Rather, itself carries with it the necessary pressure gradient that defines the incommensurability of point source field coherency, which it exhibits this neat field geometry that humans are so amused by. Magnetism is the dielectric field.
As I've said before, there is no such thing as the dielectric field. Now, Steinmetz used the phrase dielectric field to refer to electrostatic fields, and in some cases, the phrase is used to describe an electric field across a dielectric. But if the magnetic field is the dielectric field, then you are saying that they are the same thing. Now, they're related, but they're not quite the same.
Further still, a magnet does not have poles.
But the other day, I did see some poles with a magnet. Get it? Pole. Polish person holding a magnet. I'll see myself out, shall I?
This is an absurdity in the extreme, since there are no Cartesian poles in any magnet, since you could take a magnet and slice it 1,000,000 times like a log of cheese, and each slice will, of course, contain a north and a south pole.
So, to clarify, magnets do not have poles. But any magnet has a north and a south pole. Well done.
These pressure gradients require one to grasp the incommensurability and point non-specific pressure zones that define the magnetodielectric object we call the magnet. The same phenomenon is identical to the holographic paradigm, wherein which the whole is found within each and every part or section. As it happens, the most important secret of the Pythagoreans, by their own admission, was the understanding of the nature of incommensurability, or the euristostaias. This is from ahorismos, meaning without a horizon or line or location, or in the ancient Greek topos. This is the attribute of the dielectric which follows a pressure gradient expressed by actually the native prohodos, or emanationism of the ether against itself, or its extrinsic attribute, which follows 1 over 5 to the power of -3, which is actually my discovery from Plato's Republic 509d to 511 on the divided line section, and the incommensurability, the nature of the cosmos nuitos as it is mirrored within the cosmos aesthetos, meaning, the substrate cosmos, if you will, versus the phenomenal cosmos. This would be the distinction between the cosmos nuitos and the cosmos aesthetos.
You see, Poles attracting oppositionally moving ether modalities are only half of quantum dielectricity. Electrification necessitates precessional conjugation suspension, as the longitudinal time unwinding is an expanding mass manifold. That's the word salad I got from Botnick.
So, by the way, a really neat video that anybody should watch, and you could just go to YouTube and find it. Just type in Richard Feynman on magnetism. There's like about 10 copies on YouTube, and he's sitting in a high back chair with his hands folded, and there's a simple British soul who says, well, what is magnetism? What is going on between these magnets? See, he's not trying to trap Feynman. And it's okay not to know the answer to stuff. But when you pretend to know stuff and you start blathering out vomitous nonsense and fecal excrement, then you're a fool.
Again, I don't need to point out the irony here, do I?
And Richard Feynman is a fool. He squiggles and worms in his chair like a frog on a hot plate, and he eventually says something really crazy about an old lady slipping on the ice. And then he says, well, it's just too complicated for me to explain it to you. I don't have a proper frame of reference. Well, the answer, Mr. Feynman, is you haven't got a goddamn clue. Now, this guy is heralded as the cult figure of GR and QM, general relativity and quantum mechanics. He is he's dead now, but he's an extremely suave fellow, but also at the same time an idiot. It is okay to say, I don't know the answer to that, Human science has not evolved to the point where we understand magnetism. Well, we do now.
Okay, you are misrepresenting this a bit, aren't you? In the video, the interviewer asks, why do magnets repel? Now, Feynman initially gives a very superficial answer, but the interviewer pushes him on this for a deeper explanation. At which point, Feynman uses an analogy to describe why he can't answer that question in a satisfying way for the audience. And this is because, surprisingly, magnetism is a really difficult topic.
That is a very telling video, because if you look at the comments under these videos, of which there are, like I said, 6 copies on YouTube, just type in Richard Feynman on magnetism. You'll see all these general relativity and quantum mechanics idiots, and I do mean idiots in the absolute sense. Yeah, brilliant explanation, Mr. Feynman. Brilliant, brilliant. Everybody loves. He didn't explain anything. He talked about 2 old ladies slipping on the ice. He never even began to define magnetism or what a magnet is. Because a magnet before it becomes a magnet, and after, there is 0 quantitative change. So what defines a magnet? What is magnetism? Well, he doesn't know, nor does he even, there's no argument. He never even begins to explain it.
Well, he did explain something very important. He explains how there are levels of understanding and how certain levels of understanding are sufficient to do meaningful stuff, and a deeper understanding just confuses the situation. For example, to describe the moon orbiting the Earth or how to kick a satellite into space, your level of understanding doesn't need to be more sophisticated than Newton's laws of universal gravitation. Okay, and some engineering, but we'll ignore that for now. Sorry, engineers. However, if you want to describe, say, a neutron star, then this Newtonian mechanics is no longer sufficient.
But when you actually have this sort of cult following nonsense, and modern GR and QM is a cult. Mind you, it is a cult. Its priests are PhD theoretical physicists, and some are more famous than others. It is a religion. It is a cult. It's not based upon anything logical, and it is insanity. It's a pack of very deep thinkers who are, as Tesla said, quite insane. This is also interesting, and I'll leave this section here in the Department of Physics. This is University of Urbana-Champaign. Question is basically, what defines magnetism? Blah, 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 nonsense, nonsense. Electrostatic and magnetic fields involve the exchange of virtual photons. So this, children, is no different than saying someone asking, what is magnetism? And somebody with a PhD, doctoral degree. Well, it's unicorns and leprechauns. They're invisible. We can't see them. They're not the inputs or outputs of any experiments, but they make our equations balance out. Virtual photons. If you are stupid enough to believe this crap, then you too are a fool.
But once again, you fuck up a very basic point about the philosophy of science. Firstly, virtual photons have been detected in the case of dynamical casimir effects, and there is an ongoing effort to test these ideas. Hell, I nearly got involved with this myself, but then I realized that it involves a lot of maths and I'm not very good at that. But in 2011, a paper was published in Nature regarding the observation of this effect. The link is in the description. But most importantly, your attitude suggests that scientists accept the theory and don't question it. The problem is that when we say, well, it is because of this and this reason, what we are actually saying is, well, to the best of our knowledge, it is because of this and this reason. The problem is that prefacing every sentence with, well, to the best of our knowledge, is just tedious. And if we stopped questioning the theory, we wouldn't have a job. But that was enough for that noxious little toad for one day. I am not 100% sure if I should carry on with this dude. So far, he has just demonstrated that he hasn't got a clue what he is talking about. And when he is talking about his ideas, he is just spouting random words which have nothing to do with magnetism. One could say that magnetism and his nonsense are incommensurable. But thank you all for coming along and sitting through that with me. Should I do more on this series? Let me know. Actually, it doesn't really matter. I've already recorded all of them, and they will be coming out over the next few weeks or months. I would like to take a moment to thank my patrons, who are Thomas Miller, Walter Bislin, Johnny Ragadoo, Kevin Deadman, Paul Schnoos, Stringer News 1, MC Toon, Stan Steph, Cy Blacklock Hughes, Michelle Randall, Ugly German Truths, Kai Broking, and Steelman. Now, if you are a new patron and you are not on the list, then I'm very sorry. This is actually me speaking to you from the past, as I recorded this in, well, early December. I will give you a shout out in the description though. If you want to support me financially, then that would be greatly appreciated, as it will help me maintain this channel and support my beer and snacks whilst I'm writing on my thesis. But that was it from me. Thank you for watching, and until next time.
If you get hold of two magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. Now, what is it, the feeling between those two magnets?
What do you mean, what's the feeling between the two magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these two magnets together.
Listen to my question. What is the meaning when you say that there's a feeling? Of course you feel it. Now, what do you want to know?
What I want to know is what's going on between these two bits of metal.
Magnets repel each other.
And well, then what does that mean, or why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course, it's a reason. It's an excellent question. Okay. But the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens? For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. That satisfies people. It satisfies, but it wouldn't satisfy someone who came from another planet, knew nothing about things. First, you should understand why, when you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. All that is understood by people. Now, when you explain a why, you have to be in some framework that you allow something to be true. Otherwise, you're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. Not always. Some husbands aren't interested in their wife's welfare when they're drunk and they're angry. And so you begin to get a very interesting understanding of the world and all its complications. In order to if you try to follow anything up, you go deeper and deeper in various directions. For example, you could go, why did she slip on the ice? Well, ice is slippery. Everybody knows that, no problem. But you ask, why is ice slippery? That's kind of curious. Ice is extremely slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me, ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get. Greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery, because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. is capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult the why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after all. That's my idea, that the deeper a thing is, the more interesting it is. And we could even go further and say, why did she fall down when she slipped? That has to do with gravity, involved in all the planets and everything else. Never mind. It goes on and on. Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. And you say, but that's very strange, because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact, the electrical force, not magnetic exactly in that case, but it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in microscopic details. There's other forces involved, but this is connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start, what we can start with, to explain many other things that looked like they were, everybody would just accept them. You know, you can't put your hand through the chair. That's taken for granted. But that you can't put your hand through the chair when looked at more closely, why? That involves these same repulsive forces that appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than in ordinarily. And there it has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force until it's large enough at a distance that you can feel it. But it's a force which is present all the time and very common, and is in a basic force of almost, I mean, I can go a little further back if I were more technical, but at an early level, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. For example, if we say the magnets attract like as if they were connected by rubber bands, I would be cheating you. Because they're not connected by rubber bands, I shouldn't be in trouble. You'd soon ask me about the nature of the bands. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have cheated very badly, you see. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. And to tell you that that's one of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others. And those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately. That our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.